This is the video for nth roots. Let's begin. We want to be able to answer what is the difference between radical form and rational form. You're going to have to go in between the two. And then how do we simplify radicals, especially ones that are going to have variables underneath them. We've been working with square roots. So the square root of a number, square root of 16, is 4. And that's because 4 times 4 is 16. Now we're going to be working with nth roots, which is the 4th root of something, or the 5th root, or the 6th root, and so forth. So the 4th root of 16 is 2. And that's because 2 times 2 times 2 times 2 would equal 16. So that's 4 of the 2's. So the 4th root of 16 is 2. When you look here at the square root of 3 equals 3 to the 1/2 power, can you identify the pattern, how this is equal to this? Take a minute to pause the video and see if you can identify the pattern. The pattern here is that whatever is under the exponent stays as the base. You can see the 3 and the 3, the x and the x to the 5th, and this x to the 5th still. X to the cubed, or x to the 3, is x to the 3. And since this is kind of like a 1, that's why there's a 1 here. And then whatever the nth root is what becomes the denominator in this fraction. So x to the 5th, and then the 4th root, and that's why there's a 4 under here as the denominator. X, here's the x with the 1, and then the 3rd root, and that's what goes here on the denominator. So the 3rd root of x is x to the 1/3, to x to the 1/3. So if we had the 9th root of x squared, then that is equal to x and then 2/9. So x to the 2/9. That's where the 2 came from, and then the 9th root became the denominator here. So let's talk about the two forms that they were in. At first, before we changed them, they were in a radical form with the nth root. And this n, like we said, is the nth root, or the index. And then here, right here, that number or the letter, whatever it is, the variable, is called the radicand. And it's raised to this power. Now remember, we said that this equals the base to that fraction, to the power of that fraction. And so this is your rational form. This is still the base, or this is your radicand that became your base. And you can see here the m over n is your exponent. Let's do these examples together. These are in rational form, and we want to turn them into radical form. So this first one, we want to keep our base. It's going to become our radicand, so it's underneath that radical. The top number, the numerator, is the exponent that sticks with our radicand, so 1, or you don't have to write the 1 since it's just 3. And then the denominator in the rational form is my nth root. So 3 to the 1/6 power is the same as the 6th root of 3. So let's go ahead and try this second one. It should be the 5th root of 8, or 8 to the power of 1. The next one would be the 3rd root of 12 squared. So you could also write it as the 3rd root of 144. Since we know that 12 squared is 144. You can leave it like this too. The next one, we would have, instead of a number, now we have a variable. So it's the square root, or you don't have to write the 2, of x to the power of 1. Or again, you could just write it, the square root of x. So make sure that you understand how we change from rational form to radical form. If you need to redo these examples or watch this again, then do so. So now let's go ahead and go the other way. Now we've got something in the radical form, and let's write it in the rational form. That means the base with the exponent. So So remember that that nth root is the denominator in your exponent. And in this case, our nth root is, we got a square root, that's 2. So that's going to be the denominator in our exponent. Whatever's underneath this, the root, or the radicand, that's what your base is, so that becomes 51. And then whatever this power is, in this case it's just 1. So the square root of 51 becomes 51 to the 1/2 power. Over here, the third root, or the cubed root of 37, is going to be 37, 1 over 3. The fourth root of 15 cubed becomes 15 to the 3/4 power. And then the last one, we've got some variables in here, but we're still going to do it the same way. We're just going to take each one piece by piece. And we have 6 to the 1/3 power, x to the 1/3 power, and y to the 2/3 power. So we did an example of when the radicand was a variable, right? We just did that in that last slide. But just to reiterate, the square root of a squared, sometimes you'll get a fraction you can simplify. So a to the 2/2 power, which is just a, or a to the power of 1. So over here I would get, changing it to rational form, a to the 4/2 power, which is a squared. So the square root of a to the 4th is a squared. And this is how we got there. A lot of you know this to here, but this is why. And then the cubed root of a to the 9th is a to the power of 9/3, which is a to the power of 3, or a cubed. So what's the cubed root of a to the 9th? It's a cubed. Again, if we have more than one radicand, just like we did in that example, you just have to take one at a time. So here we have x to the 2/2, y to the 4/2. They simplify and you get x y squared. So the square root of x squared, y to the 4th, is xy squared. Over here we have 9, the square root of 9, or 9 to the 1/2, x to the 4/2, and y to the 6/2. This simplifies y3rd. This is x squared. This can stay as 9 to the 1/2, but what we have to start doing is realizing that it's 3. Okay, so if it wants you to put it in rational form, we can leave it here. But if we're simplifying, then we would put 3. Okay, so this is rational form and it's totally fine. But simplifying, see how we can, this is okay in rational form, but when we simplify our exponents, they become smaller. So when we simplify the square root of 9, which is 9 to the 1/2, it's 3. So the square root of 9, x to the 4th, y to the 6th, is 3x squared, y cubed. Okay, what gets trickier is when the exponent is not divisible by that index number. So before, with all the examples, when we simplified that fraction, right, like x to the 4/2, it was divided nice. It became x squared. Well, what happens when you have x to the 5/2? When we want to leave it in rational form, that's okay. When we want to simplify it, this is not okay. We don't like fractions in our exponents. Okay, so again, when we want to simplify, there should be no fractions in the exponents. Okay. Alright, so let's come over here and start simplifying. Okay, we can turn these into rational form, again, like we did, and simplify. If I can look right away, this is going to be y5 to the over 2. So that rational form is not going to help me all that much. So the way that, there's different ways to do it. The way I like to simplify them is to split them up. You can split up the square roots of all of these. Okay, so I'll do that first. So I've got the square root of 36 times the square root of x to the 6th times the square root of y to the 5th. Now I'm going to take them one at a time. I know the square root of 36, that's 6, so I'm good there. The square root of x to the 6th, I can put that into rational form, x 6/2, and that's x cubed. So I can do that. This one doesn't work as well, right? y to the 5 over 2 is not going to divide. We don't want fractions in our exponents, so this is what we do. We can split this up again so it does divide. So y to the 5th, I can turn it into y to the 4th times y to the 1, or y. That's because I still have 5 total y's. So square root of y to the 4th times square root of y is the same thing as square root of y to the 5th. I just wrote it differently to simplify it. So now y to the 4 over 2 is y squared. Because this doesn't simplify, I'm going to leave it there. So my final answer is 6x cubed y squared square root of y, or radical y. This is in radical form. I used rational form to help me simplify, and this is my answer. So the square root of this is this, and you can leave that radical y there. All right, so let's try this other example. I can tell we don't have a square root of 10. We don't know what that is. We can't divide 3 divided by 2. It's going to leave us with fractions in our exponents, so we're going to need to simplify. Break it all up. So I've got the square root of 10 times the square root of x cubed times the square root of y times the square root of z squared. All I did was break these up in their own radicals so they can be simplified by themselves. Square root of 10 is not going to do anything, right? There's no other way to simplify it, so I'm going to leave it there. I can break up square root of x cubed into the square root of x squared times the square root of x. And then the square root of x squared becomes x2 over 2, which is just x. Whereas this square root of x doesn't do anything else. Okay. Now I'm splitting up, and then the square root of y doesn't do anything else. You can't simplify it anymore. Okay. And then z squared, we can. That's easy. Z 2 over 2, which is just z. The square root of z squared is z. So if you need to go through the rational form, that's good. If not, you can see that there. So I can go back and I can circle everything that's the most simplified. Square root of 10, x, square root of x, square root of y, and z. And that's my answer. I've got to put it all together. Okay. What I want is anything left in the square root needs to stay together. Put them back together under the square root. And anything that made it out is together in the front. So I have x, z from here and here. And then under the radical is a 10, an x, and a y. So that's my answer. So the square root of 10x cubed yz squared is xz radical 10xy. Alright, so I want you to try this one on your own. I want you to do the best you can. We know like 13 won't divide by 5. 10 will, but 9 won't. So you're going to need to split them up by themselves. Right? So this would become the 5th root of x to the 13 times the 5th root of y10 times the 5th root of z to the 9th. So I want you to pause it, and I want you to work this by yourself and see what you get. You might get it wrong, that's okay. So pause it, and then I'll explain it when you're finished. Alright, so here's how you work this problem. So 13 divided by 5 doesn't work, right? So we want to split this up so I can get as many x's out as possible. So I'm going to split this into the 5th root of x to the 10 times the 5th root of x cubed. Because 10 divided by 5 will work, and this is 3 divided by 5 won't, and there won't leave me any more in there. So this becomes 10 divided by 5, which is x squared. This won't do anything else. Okay, I can't simplify it anymore. Now, y to the 10 over 5, that divides, becomes y squared. So that's good. That was easier. And then 5th root of z to the 9th it's not as nice as this one, won't divide nice in that fraction, so we're going to split it up. I've got the 5th root of z to the 5th, and then the 5th root of z to the 4th. I split it into 5 and 4, so this will divide. Okay, this won't, so it'll be left under there. So there's nothing else to do here. But this will, and it'll become z 5 over 5, which is just z. Okay, so here are my answers. Whatever's left in the radical stays. Whatever's not is what you do first. So I've got x squared, y squared, z. And then I have the 5th root of x cubed and the 5th root of z to the 4th. So 5th root of x cubed z to the 4th. That's my answer here. Don't forget to answer your essential question in the summary, write your other questions, and then you need to have a basic understanding of this before you come to class. So go back through your examples, go back through your notes, we'll rewatch the video if you need to, and then come into class at least basically understanding it, and then we'll have lots of practice in class. That's it. Thanks.